All right, how is everybody doing? I'm going live. I want to turn down my music just a touch. Hopefully that's not distracting. If so, it can be turned off. But anyway, it's been a while since I've done a live stream. It's good to see all of you who have joined me in the chat this evening. So thank you very much for joining me live. If you don't know me, I'm Kersey. I run this channel, Kersey Fabrications. I've been doing 3D printing for a long time. I am a software developer by day, though, and so I've been wanting to incorporate more and more of my software development and what I do kind of as my hobby side of that for a long time. So what I'm going to do here tonight is I've got a brand new board. I'm going to go through the documentation to set it up properly. This is supposed to be both educational as well as just walk you around through this if you haven't seen it before. This ties directly into the work that I've been doing on my Iron Man project, which I have codenamed OASIS. And that project is building the most feature-rich, most just real-time and realistic version of what was originally an Iron Man helmet. And there's going to be more and more content on that coming. I've been doing a lot of coding on that for a little while now. Hopefully the audio is coming in good. Like I said, it's been a while since I've done a live stream. I've only done one or two other ones from this location before, my secret lair here, instead of the garage of the secret lair. And so I hope this works well for people. Since this is the kind of work, it's not real hands-on, I'm not 3D printing anything, being at my desk here is just a much more comfortable way to do this kind of thing. So again, I've got the chat up here. I'm doing this live. I'm going to walk you through exactly what we're doing. We got some hardware hands-on stuff as well as some software stuff that I'm going to be doing on my Linux laptop. So it's going to be kind of a range of stuff. I don't know how long this stream is going to last, as long as it takes to get this up and running. If the up and running part takes too long, then there's a good chance that I will stop at that point where I have it up and running. But I really, if this goes pretty quickly and everything works well, then I may actually get my OASIS software running on here too, just to show that all of the software and everything's installed. But that does have some dependencies that may make compiling and stuff take a little bit longer. So anyway, let me see what I want to do to start here today. Let's show you the product that I'm going to be installing, and then I'm going to take a step back from the product. And then we will just talk about Jetson and Linux, and we'll do all of that as I'm going through this. I apologize if I don't always look at the camera this evening. I'm used to this being more of my workspace, so looking at the camera and looking at who I'm talking to rather than staring directly into the camera. So I have to switch modes here. But again, I appreciate we got Manny in the chat. Thanks, Manny, for joining me here. I'll call you out if I see you chatting. I'll call you out, say, hey, I'm looking forward to the evening. And if you haven't done so already, hit the like button for me. Let people know we're watching this chat. And if you're on socials, please feel free to share this with your socials. Let people know what I'm doing here. All right, so let's start out. I'm just going to jump into the board that we're going to be using here today. So let me go and switch to the desk camera. The desk camera here, and so let me show you what I've got. This is by a company called ARK Electronics. This is an American company, and they primarily focus on drone components, but this is one of those cases where components for one industry can be ideal for another industry. And so again, this is meant for a drone. That is not going to be how, at least initially, I'm using it. I'm not saying I won't be putting this into a drone at some point, or maybe another one of these. But for right now, I needed something that had battery inputs for my Iron Man suit. And I've been powering the usual Jetson board off of just a big laptop battery. It's not ideal. I can't monitor the battery usage via software in any easy way. So I'm always looking down to see what my percentage is by looking at the side of the battery, which is kind of a pain. So I was looking for a component. Number one, it has to be a very small form factor because, again, I'm wearing it. Number 2, battery power and battery power monitoring. I have to know what the battery level is. Again, so I reached out, ARK Electronics. I'm on LinkedIn. If you're on LinkedIn there, please feel free to reach out, and we'll link up there. But I've been following these guys, the ARK Electronics guys, on LinkedIn for quite some time. They make some amazing, very small form factor, high engineering quality products, again, here in the United States, for the U.S. drone market. They sent this over to me. This is the packaging it came out, and they came out with a little magnet. Again, I just, off the cuff, they sent me this. This is a prototype one of their boards. It has a couple of known issues I'm not worried about for this demo and for me trying it out. But again, they were kind enough to send this over to me. No sponsorship or anything like that. They were nice enough to work with me on this one. So let me, I'm going to get my strap. I don't want to blow one of these boards up anytime soon. So I do have an electronic strap that will be grounding me. It's off to the side here. You won't see it. So let me show you what this looks like. And there it is. So that is the ARK Electronics board that we're going to be using. This is called Just-A-Jetson. Because as you can see, there's Just-A-Jetson right here. But as you can see, this board is very small, has a number of very small form factor inputs and outputs. It does have CSI 1 and CSI 2 connectors for stereo cameras. As you can see, some of these, I won't go over all of this here on the board because I don't know them all off the top of my head yet. But we got some USB headers. We've got different GPIOs on here. This is a 5-volt input to power the board off of. This is the XT60 input. This is the one I'm primarily going to be using. As well as, I believe, if I'm not mistaken, I think this is an XT30 output. But either way, it's a battery output that you can use as well that will be powered off of this one. As you can see, a lot of the components are surface mount in a way, kind of like an embedded system more than a PC. And I'll show you the regular Jetson here in a minute. But what we've got here, we've got a couple of USB ports. And like I said, some of these ports around here are also USB. But these are the easy to access, keyboard and mouse type ports. There's an HDMI port for video output. This is the USB-C port, which I believe is their flashing port. And then we have a regular RJ45 network interface port. I believe that's going to be, yes, that is gigabit Ethernet. So I didn't want to say that if I was wrong on that one. But there we go. That is the board. And as you can see, very compact. On the back here, we have a M.2 M key, a 2242. This is for your solid state drive. And then we have a M.2 key E 2230 port, and this one is for the Wi Fi card. I'll be showing you those in a minute. But that is all for that board. And we've got a fan header here. This is the 4-pin fan header that is typical with the Jetson. And then this is the SIM slot, which will go straight into there. All right. That is the board we're going to be installing in just a moment. And as I was saying, this is a SSD. So this is a M.2 2242, which should match up as that 2242 that I have there on the back. And this is a 1 terabyte drive. And we will bust into that in a minute. Along with that, I wanted an easy way for me to power this on the desk. So I found these USB-C to XT60 connectors. I thought that would be convenient. I can power everything with USB-C. And I needed all these fancy... So these are... The connectors you saw on that board are all kind of... at least as far as I know, they're pretty specific to the drone industry. But luckily I was able to go on Amazon and buy a whole pack of connectors. So that is a pretty nice pre-crimped connectors that I can use when putting together this with my suit and my various components. All right, so I think that's all I'm going to need. You notice I haven't mentioned a Wi-Fi, I haven't mentioned the Jetson yet. We're going to be talking about those here in just a minute. And again, if you have any questions while I'm doing this, please feel free to just drop it in the chat. I will answer any questions about this as we go along. Anything that I don't cover, please let me know. All right, so what are we installing in there? This is one of my NVIDIA Jetsons, and this is the one we'll be transporting or transferring over to the new system. This is one I've already modified, so some of this stuff is not stock on here. So this is pretty much the standard form factor of an NVIDIA Jetson. This is an NVIDIA Jetson Orin Nano, 8 GB. This is the one that you get in the development kit if you buy a development kit. Again, pretty standard. This is the module that we will be removing to put onto that other board. As you can see, I already have, this one already works. I actually tested this right before the stream to make sure that this one was up and running and everything was ready before I tried to install it onto that new board. This is the hard drive on this one, and this Wi-Fi adapter here will be the one that we're transplanting onto that other board. As you can see, this one's by another manufacturer, but this one, like I said, works fine, but it does not have the connectors, doesn't have the battery power that I need, which is why I reached out to ARK for this particular project. And again, I've got these crazy long antennas here. This was to get the best Wi-Fi coverage out of this I could. Doesn't matter. The ones on the typical Jetson are much shorter than this. Excuse me while I take a drink during this stream just to keep myself hydrated. All right. I'm going to bring that audio up just a little bit more because I can't hear it anymore. I like to have a little jam while I'm working. All right, so let's go ahead. We're going to go ahead and get all this transferred. Actually, before I do that, let me show you the guide. So I think I want to do the Jetson input here. All right, this is on my laptop. I'm going to be a little sideways here as I'm doing this. So this is ARK's Just-A-Jetson page, as I was mentioning. They have the pinouts on here, the flashing guide, all of the connections, a block diagram of everything that's on this system. They even have a 3D model that you can, I believe, download. Yep. So this. So this is a 3D model in case you're doing development. There's a step model that you can use to build your own enclosure for this. I will be doing that when it comes time to install this into my helmet or my suit or wherever it's going. I will be downloading this step model and actually doing this using a Fusion 360. It's a fantastic piece for a manufacturer to provide, particularly since they're providing it on a GitHub repo like this rather than having to go through some sort of lengthy process to actually get them to release it to you. And as you can see, also there's a PDF here which will load in browser. Hopefully it'll load in browser. Maybe not. We'll blame GitHub on that one. But anyway, going back to this, that was the 3D model. Again, they have a block diagram of all of the components. So this is obviously where your Jetson Orin is going to plug in. Gigabit HDMI. They have, this looks like all the electrical side, voltage regulators, diodes, all that good stuff, overcurrent protection. That is all in there. And as I mentioned, they also have a pinout diagram. So this is all what I was telling you just a minute ago. They have the UARTs that are output. So if you just need UART to attach to an external input. The CSI connectors, again, they have a CAN bus on here, which if you're into automotive and all sorts of things are adding CAN buses these days. I know 3D printers are adding them. I'm assuming this means that drones have them also these days. We've got, again, USB headers and again, battery output, battery input. There's a 5-volt input specialty header that I was showing you a minute ago. And then we have the fan header as well as the force recovery, which on this one, so typically when you go to install on your Jetson, You have to short some of these pins out in order to get it to boot into recovery mode. It's kind of a pain. You have to find a jumper, you have to get a screwdriver. Hopefully you don't short anything else out. But I noticed when I was looking at their block diagram, their recovery is actually going to a button, which makes life a lot easier when it's time to reflash these things. All right, so back to this. So that's the Jetson, and there's a there's a reverse side as well. All of the various signals, everything you need to wire this up, they've provided for you. Again, like I said, I really like it because it's provided without any NDAs or anything to get all the information. It's really nice. And then there's the flashing guide, which is what we're going to be doing here today. Notice, you can get it pre-installed if you buy it as a kit, and everything will be ready to go. Or, as with mine, it's just a board. So I'm going to come in here and click on their GitHub repo. Actually, let me do that a little bit different. Let me click on this one. All right. And then this is the carrier setup. It contains instructions and scripts for flashing it. Clone the repo, host PC, yada yada. This is my host PC again. This is a Linux based laptop. I will need a Linux machine to do this, I believe. Don't know all the other options. You could be running Windows with some sort of virtual machine, or potentially a container or something. Tells me all of this: setup, script, download. We're going to run setup. Once the setup script is finished, you can build the kernel. We're going to add the Wi-Fi network. Then we're going to go through the flashing. Once it's done, we should be able to SSH into it. That'll tell us whether it's working or not. And then there's they have an ARK software package called ARK-OS, which I am not familiar with, but let's see, Pi 6X. My guess is this going to be a drone-centric, ARK-OS collection of software services and tools for drones. Okay, so we will probably not be going through that part in this video today, since, again, my initial target is not droning. Anyway, let's go ahead, do the hardware installation side of things. Then we will move on to the software side. All right, so for the hardware side, again, this is our board. The first thing we need to do with this is actually disassemble. So let's take apart this one with all the pieces we need, and then we will be ready to install it onto the new system. Let's put it here nice where everybody can see what we're doing. The first thing we're going to be doing, I'm sorry if the lighting isn't great here. I don't have like studio lighting or something set up for this teardown on this desk. I thought this lighting would be pretty good. We'll see how the camera does with it. Again, I'm going to let's pull the fan header off of the board. And then there are 2 screws holding this on. Looks like the camera's struggling a little bit, but it's not too bad. Alright, so pull that off. We're going to need to reuse all of these screws because my board did not come with screws of its own. And we're going to pull these little tabs on the side, and that will pop the module out. Alright, so that is the Jetson module. Alright, normally the Nano line has this SD card slot. We're going to try not to use the SD card slot because we want to run directly off of that SSD instead. But this is the back of it. You can see this is the mounting mechanism for the heatsink. Heatsink is just a single fan. Pretty standard. All right, let's flip this over. Again, we're not going to use this SSD. Hey, Chris, why are we not using this SSD? Well, we're not using this SSD because it is because it's too long. It will not fit that other board. That other board's a little bit more compact, and so it does not have enough room for this SSD. But we are going to use, man, I put that one on there pretty good. All right, but we are going to use the Wi-Fi adapter. Get this off of here, again, saving the screws if I don't lose them. Hopefully everything's the right size screw. And just pull that straight out. go. That'll work. Again, I kind of wish I didn't have these long Wi-Fi connectors on here, but it's fine. That should be all we need off of here. Now this one can go back into the box. We'll save it for next time. Okay. Alrighty. Okay. Let's grab the board. Let's start with the back side. Let's put these new things on the back. I do need to open up my SSD card. Grab some scissors. 5-year warranty on this, and I did try to pick one with a pretty good data rate on this. So hopefully it gives me pretty good performance. Let's see if they have a known way to open this. I don't see any particular lines or anything that shows me how to get this out of here. There we go. They did not make that complicated. Not complicated at all. All right. Let's get this out of here. How they include these little side places like that's going to help a lot. Okay, there's a terabyte in the palm of my hand. And this one's going to go on the 2242 side. It should just slide right in. And let's go ahead and see if this is the same size. I don't know if it is. If it's not, I'm going to have to go find something, because, yeah, that does not fit. This is not the right size screw. Okay. All right. Let's go ahead and see if this one fits. Nope, that one doesn't fit either. I'll be running off looking for screws here in a minute. I didn't know that would be a problem. And this one looks like it's not going to fit either one of them either. Be running off to find some screws. I may have some sitting here near me somewhere. Yeah, that one doesn't fit either. Something smaller. Let's see what I got here. It's funny when you sit around and there's just screws, so never know what's going to fit. Let's see, do these fit? No, that one doesn't fit either. Oh darn. Let me see what I can find real quick. Switch over to this one. Something more interesting to look at. But I don't know what I have. Let's see. I've got plenty in the garage. I just didn't want to have to run off and leave you guys a while. I'll go find some screws. See, I've got a whole bin of screws over here that all look the wrong size. Those are a different kind of screws. Those are plastic screws. Alright, we're going to work this out. Let me take the headphones off for a second. I'm still in the room. I am just seeing what is nearby so that I don't have to go running off too far. Hopefully you still hear me alright. Like I said, it's just a matter of... I assumed that these would be standardized screw sizes, and they do not appear to be. Huh. Alright, so here's what I'm going to do. I'm going to be right back. I've got to run this down to the garage and find the correct size screw. And then run right back up here. So hopefully, let me go and chat. Be right back. Grabbing some screws. And that's unfortunate, but there we go. So at least people know where I have run off to if they can't find me. So chat amongst yourselves. I'm going to go run this board down and make sure I get the right size screw. I'm guessing these are going to be like M2s, M2.5s. But let me go see what I can find. I will be right back, everyone. Sorry to waste your time. Alright, I am back. Sorry about that. But I think I brought enough screws to figure out the job. Alright, so let me just say back. Alright, thanks everyone for hanging out and not abandoning me. I told you it wouldn't be long. So, let's go. So I'm not sure what size I'm going to need. So I brought, there we go. Brought a number of options here. We've got 2.5s and I've got 2s. I'm gonna grab one of these small. You know what? I just realized it's the wrong size screwdriver because most of my screws are hex. So luckily I've got my other bits here. Let me find out the one I need for this. Let's see. So I'm gonna try one of these like 4 millimeter 2.5s. I just need the right size screwdriver to put it in. All right, let's figure this out. Nope, can't find the right size screw yet, but here we go. Thank you very much, T. Appreciate it. Liking my green screen background. It does work well. All right. Let's give this a shot. Give NVIDIA credit for this background. Their graphics card's killing it. It's doing all the heavy lifting. So, all right. Let's try this. See if I've got the right size screw here. Let's see if I got lucky. So this is, again, this is a M2.5 by 4. No, not 2.5s either. Wow. Okay, I really thought it was going to be a 2.5. I guess we'll try the M2s because I brought those also. Let's take a look. Hopefully I have some that are short enough. These are M2. These are Phillips, so I get to switch back to my other screwdriver. Luckily that's not a pain in the butt with this one. Let's see if that fits this. So this is an M2 by 5. Let's see if this one holds it down. It is the right size, but I don't think it's going to hold down this card. I don't think it, yeah, it just misses it. The head's not big enough. So luckily, I have some washers. So we're going to rig this thing up until it works. So I'm going to take one of these M2 washers. It is the right size washer. It should ground this properly, which is the main thing I'm worried about. But it is an M2 screw. You'd need some slightly larger heads though, but that looks fine. Nothing is going to short out from that at all. So let me grab another set of those because I need one for the Wi-Fi card. Alright, so let's do the Wi-Fi card. Should just work. Slide that one in here. Yep, that just works. And we're going to use the same, just put that right on top of it, but nonetheless, we're going to grab that washer, and we're going to do the same. We're just going to drop it. That's what we're going to do. We're going to drop the daggum screw and lose it now that I've gone to all that trouble to find one. Alright. Let's see if I can get this in here without dropping it. Apparently I should have grabbed a magnetic screwdriver. Would have been a whole lot more useful, particularly with as small as this is. Put this over here so you can see what I'm doing. And we're just going to tighten that down. Again, be very careful. Don't over tighten this. These PCBs don't need it. They don't want it. So there we go. Didn't mention earlier, this one actually does have a PCIe connector. I assume that this will work with a lot of those new PCIe peripherals that are available for like the Raspberry Pi. But I don't want to speak for the company. I haven't tried any of them, obviously, but that is a nice PCIe header on there for some daughter boards or something. If nothing else, you can get like a PCIe expander possibly. I don't know. Okay, we're going to switch over to this. This will slot in here. Alright, we just slot it in and then lay it down. And that is it. We make sure our clips are good. And then we are going to hope that these are the right size screws. And then they go exactly the same place the last ones went. Yep, those do still fit. Although, I'm starting to question if they're too long. Are they too long? The stock ones are too long. Are these M2.5s? Or are we dealing with M3s? What are we dealing with? Because I got the M2.5s over here if I need them. But I do think that these are too long. We're bottoming out. Yep, we're bottoming out. Alright. I mean, you don't technically have to have these. I'd want to put them in there before I did anything rough with this, obviously. But looks like I could use some M2.5s. Let me see what I've got. Let me see if these are 2.5s. They definitely look bigger than the other ones. So let's just grab it a 2.5 by 4. Let's try a 2.5 by 4. Let's see if that does that fit in there. It does. Okay. So these are in 2.5s, and the 2.5 by 4s that I have seem to be working just fine. Good to see everyone coming into the chat. Thanks for joining this evening. Feel free to say hi when you pop in. It's good to see everyone. Again, we're building up a new NVIDIA Jetson board, and everyone's free to ask questions. Again, this board's by ARK, an American-made drone company. Hopefully, I'm not selling them short, but that's how I know them. And then once we get the board all in, I'm going to make sure that I get this header turned right and plug in the fan header. Alright. Yay, okay. So the fan header goes right there. And I think this board from a hardware perspective is done. That's all the hardware components. Hey MJ, welcome into the chat. Thanks for joining. Alright, so that is it for the hardware. Again, these are my Wi-Fi antenna. Power for the board's going to come in here. I'm going to hook up to my host machine with this one in a few minutes. I am now going to clean up my workspace a little bit. One thing I want to do so that I don't lose these original screws in case I ever need to go back to this board the original board I started with, I'm actually going to save those screws off by just putting them back in the original board. Let me go ahead and do that. There we go. Because they don't fit into the ARK, they are fine to save on this board for later. Thanks everyone for hanging out. Again, this one already still has the OS and everything for this board on it, so theoretically I might be able to reuse that in case I ever do come back to this board or switch to a different board entirely. Alright, saved off. Let's do it. Okay, so hardware-wise, we're all done. There's not much that I can check here. I could power it on, see if LEDs and such come on. That might be worth the time, but at this point, I think I'm just going to switch over to software. Get going on the software side because there may be, you know, several things I have to do from a hardware perspective, a software perspective to get this going. All right, so let me turn sideways here. Again, working on my Linux workstation here for this one. So we're going to switch over to this one right here. Again, using the GitHub ARK Just-A-Jetson repo. This one's just all their Jetson kernels apparently. So installing, we're going to run the script, yada yada yada. So the first thing we need to do is we need to actually pull down. Let me do this real quick. Alright, the first thing we need to do is actually pull down this Git repo because we need all of these scripts and everything on here to get going. So, bring up a terminal. Directory, ARK, Jetson. Let's try that. And I'm going to rename it because I didn't like the way I spelled that. Oh, I still can't spell it. Wow, this is what you get for typing on a stream. Let's be more careful. Alright, there we go. I will CD into there. I'm going to pull down this code. We're going to grab that clipboard link. And we're going to git clone. And I don't know how much this environment is set up and ready for all of this at this point because I haven't done a lot on this install. This is a fairly new laptop for me, so I haven't gotten it all set up at this point. So if I'm missing any tools or anything and we have to pull those from Linux, you'll see that live as well. Again, Git's not even found, so we're gonna need to install some tools clearly. I have not gotten this laptop set up completely, so we're gonna git apt install. I think if we do, I want the build essentials. Yeah, let's start with that. I think that's going to cover most of the things. Hopefully my hands are not anywhere when people can see when I'm typing. That's good. Okay, that's already been installed. I don't know how Git was missing. Alright, so let's pull that down. Yes, we want to pull down all the Git packages. Alright, that git clone should work now. Alright, easy peasy. Alright, so let's go into that directory. Now we basically start through the process and we're going to follow along. Hopefully that's big enough. It looks like it's big enough. If anyone can't see what I'm doing, if it's too small, increase the size of it. Obviously I can come in here and increase mine a little bit because I want you to be able to see it easily. That might be a bit much. That seems a bit much for me. Getting older, but not that much older. Alright, so let's go ahead and pull that over here. And then we'll do the Chrome next to it. Yeah, alright. Now I should be able to do both of these at the same time. Alright, run the setup script to download and build the JetPack. Alright, we're going to try that first. We're going to see if their setup and everything works. We're going to set up. Hopefully this pulls down pretty quick. If anything gets too big, I will hardwire it, because right now I'm on wireless. But my wireless in my house should be pretty good to pull this down. I'm pulling 10 megs a second. That's not too bad. Alright, again, hopefully everybody's doing good. Thanks for everyone joining me this evening. Again, we're getting a brand new NVIDIA Jetson board up and running from scratch, following the instructions by the manufacturer. Again, this is by ARK. And as we get going, we talk about other things. I'll be happy to talk about the OASIS project if anyone wants to talk about Iron Man builds, or how you get a working HUD in an Iron Man helmet. I mean, that's what all this is for, is taking this little board and getting it into an Iron Man suit so it can power the Iron Man suit, running an LLM, so you get a real-time Friday or Jarvis, as well as doing the real-time HUD duties. So this one's going to be pretty. Maybe I should have run setup first, but I really did want to show everything that was involved in this process on camera. So that's what this is. If you're watching this now, hopefully I will have a chance to edit this down. We'll turn it into a full-featured video or something as well. This isn't too bad. We're still pulling 10 megs a second. It's not slow by any means. Taking a look at what else we have here today. Let's switch back to the desk camera while that's pulling down. You guys don't need to see it download, obviously. So again, when it comes time to flash it, we'll be most likely flashing it over this USB-C port. And we have Wi-Fi as an option. We have Ethernet as an option if you're building a small local area network, and whatever you're building, even embedded can have a small local area network. We've got the UART pins here. Again, we can do CSI for cameras, which is what I'm currently doing in my suit, is CSI. But I have recently found these nice global shutter cameras, which will run up to 90 frames per second. And these are real contenders for going in the suit. You can also see they're very low profile, which is really hard to find. So these are contenders, and I think that if we get to the point where I can start pulling things down and compiling some things, and there's time still in this stream, then I will be using these cameras to test with. This is all on a USB hub. I have dual cameras. I got a keyboard and mouse, a separate monitor to hook onto this. Once we get all of the installation and everything done, and what I'm going to do, I'm going to swap these. I just realized because of the way the screen is oriented. Once, okay, sorry. I got all this on-screen stuff that's getting in the way. It just delete me. No one wants to see me. And again, I'm not sure if people want to see these anymore. We could move these up here. Move that up there. That's a better place for it than where it was. That's fine with me. All right, let's do that instead. All right, again, as I was saying, once this is done with the setup side and everything and is on the device, we will switch over to the device and get everything running there, and I can switch to the HDMI to that output instead, and it should work just fine. Downloading pretty good. It's downloaded over 1.5 gigs already. So this is, you can see it's pulling down the root file system for Tegra. Tegra being the Jetson platform. There you go. It's gonna untar everything. This may take some time. It shouldn't take too long. It's a pretty spiffy laptop. This one doesn't come with a gauge of any sort for me to know how long it's going to take. One thing I can share with you while this is downloading or untarring. Let's go ahead and talk about what's that? That's not the one I wanted. Let's do this. All right. So this is the daughter board, or excuse me, this is the board that I have built. This contains all of the sensors and everything that goes into my Iron Man helmet. You can see this is a GPS. We have a IMU, which is inertial measurement unit sensor. I don't know why this camera doesn't want to stay in focus. But anyway, this is the inertial measurement unit sensor. We've got 2 environmental sensors, one for CO2 levels and one for like how much gases are in the air, potentially harmful. And then on the back side, I have an ESP32 that runs it all with a TFT on it. And this display shows all the debugging information you would need to debug what's going on in your environment or on this little board without actually having to plug it into a computer, which is really nice. And we can plug this in later. I can show this to you if we get a chance. But this is my nice board. And over here on the side, we have outputs for both LEDs as well as servos. And there's also a place for buttons so you can open and close your helmet. And then if I ever need it, I've got like a little 5-volt input here that you could run to something, like a power brick or something. But currently, this thing actually runs really well off of a 5-volt input off of this USB-C header. So I'm not having any problems running it there. Okay, let's see how we're doing. There we go, just finished. Now it's pulling more stuff down, doing some more installation for us, doing a lot of unpacking. This is great. Looks like some hardy shell scripting here to make this easier on us. Doing all of these installs. We got some Jetson installs, some bootloader, we got CUDA. So it's building the complete file system for our Jetson here. There's the kernel. That's the Linux kernel. The core of the operating system, if you're not familiar. It's putting a bunch of configuration stuff on there for us. We're still up in the setup.sh section. Looks like we're pulling down some public sources. Most likely the kernel sources. And downloading pretty speedy. These are the Jetson sources. They may have other stuff in there besides just the kernel. A second, let me check on something. My mom was calling earlier, and I guess she doesn't know that I'm live streaming this evening. Hey, everyone, call your mom, text your mom back. Alright, we're extracting the bootlin toolchain. We're basically installing a bunch of sources right now so that we can build the framework for this from scratch, which is what we're doing here. So what's great about this, clearly a lot of this is open source, starting with the NVIDIA Jetson sources. And then what they've done in this is just provide all of the tools, the shell scripting, everything you need to make sure you can build it specifically for this hardware platform so that you get up and running. It's a manual way of doing it, but I think they suspect that most people that are going to be buying a board of this kind of building a custom solution, know what they're doing, even maybe even appreciate the fact that they've provided a bunch of shell scripts in case they need to modify something and want to replicate what they're doing. So I think this is a good move on ARK's part. Just as it says now we can build the kernel. That only took 9 minutes and 21 seconds according to their script, which is pretty cool. So let's go ahead and grab that. And do that. All right. There's two different platforms. PAB, I think, is a different Jetson board that they have. I'm assuming JAJ is Just-A-Jetson. And so if that's the case, let's go ahead and choose 2. And it is now building our kernel for us. It went ahead and pulled down the configuration files that was already part of this repo, most likely. I noticed that there was some stuff for, let me go back up here to the top. There's a device tree, for example, that's already in here. Yeah, there's view all the files, and now we can see there's some more shell scripts that they're doing. Anyway, I'm hearing my laptop spin up. We're definitely compiling. So we're going to compile that kernel for scratch for the Just-A-Jetson, and then once we're done with that, it looks like we can just add that kernel, or excuse me, add our Wi-Fi information, which I will go ahead and do, but I'll have to go away for a second while I do that so you guys don't know all my secrets. Again, thanks everyone for hopping in. We've got 21 people viewing at the moment. If you haven't done so already, please hit a like on the video. It helps, it helps the algorithm, let other people know what I'm doing here. Again, if you're just popping in while this is building, we don't have to watch all of that, but I do want to show you this is the Just-A-Jetson by ARK. And we've already done the hardware installation part. I should have the recording of this as well as a cut down video of it later. So there is the Just-A-Jetson by ARK. It already has the Orin NX 8GB on here, as well as a 1TB drive and a Wi-Fi adapter already installed. That's what we did earlier. So you can see there's still room for expansion. There's a PCIe header here, as well as a bunch of specialized drone connectors, which I was able to get off of Amazon. Nice little connector pack that should give me almost all, if not all, the connectors that are already on here. Right now, we're just building this kernel. Right there. So we're still building this kernel, and when that kernel is done building, we will begin transferring it over to the system over USB-C. I only expect this to take like a couple of minutes, just in case you're wondering how long this is going to take me. I expect it to take a couple of minutes. It's a pretty big kernel, but I have a pretty fast laptop, and it's probably knocking it out. We want to see. Let's see how much this is using to build it. So I got a lot of cores here. It's using them all, so this should go pretty fast. Yeah, as you are hanging out here and as we have some downtime while it's compiling or while it's copying or cool things like that, just let me know if you have any questions. I'm happy to answer them in the chat, so give it a shot. Also, if you're in the chat, let me know why you're here. Let me know if you're an old-timer from the channel and you've been watching me for a few years now, or if you just showed up because you saw NVIDIA or Jetson or embedded in the title, whatever I put here, or Just-A-Jetson. Let me know why you're here. Happy to chat. Let me know what you're interested in. Let me know if this is the kind of content that you like. Let's see, let's go in. Oh, it's almost done. See. All right. Just-A-Jetson. What are we doing with this device? Good question, Charles. Thanks for asking. I am going to, so let me answer this in two ways. First of all, what's it normally used for? Normally this wow, that's hard to say fast. Normally, this Just-A-Jetson is used in devices like drones. It's the reason it's so small and compact is because, there we go. Oh, look, it's just completely blacking it out. The reason it's so small and light is because it is designed for a drone, and you'll notice, like I was telling earlier in the stream, the reason I chose this one is because it has a battery input, which is real special for something that you want to take mobile. So it's got this XT60 connector for a battery input. You can run this off of a LiPo battery, just like you would run in a drone, and it should run a good long time off of one of those. Relatively low voltage. It's going to be more efficient. It also has a little battery output if you need to go to other devices. Now, what I'm doing with it is I'm building an Iron Man suit that has the most technology you've ever seen in an Iron Man suit before, at least a hobbyist one. It's got a full heads-up display, which is what the Jetson is for. It has a AI assistant. I call it Mine Friday. People are used to Jarvis. So that's what I'm doing with mine. It's going to run an entire Iron Man suit. It's got a bunch of devices all over the suit. We've got environmental sensing. We've got lights. We've got motors. We've got, again, the entire heads-up display, which I'm going to be talking about. If we get this thing running pretty quickly, I will run my heads-up display code, which I don't know if anyone's even seen my latest code that I've been working on for several months. I've been doing a lot of upgrades. So if I can get all that up and running in a pretty good amount of time, we will show all that off in this stream. We've only been going for an hour. That included a lot of background information. That also included the hardware setup, which is already done on this board. I've already got the module as well as the Wi Fi and the solid state drive installed. So far, installation has been going beautifully. Their scripts are working really well so far. Knock on fake wood table. And it's already into building the modules for the kernel. You see all those M's on the left. I can walk you through kind of what we're looking at here. These M's mean that it's building all of these as modules. And so we're already done with the core of the kernel. The part that it loads is one component, and then these are all the modular portions. And once these are done, we will be able to move on to flashing it in just a minute. And the board's about ready to go for that. Seems like this is entering a sweeter time for people. Started out kind of slow on the stream, but we're getting more and more people joining us as we go along. Thanks for everyone logging in. If you're listening, please hit that like button for me. It shows me that you're here. Shows me that you want other people to join us. And again, thanks, Charles, for the question. I appreciate it. If you're new to the channel, I've been known for 3D printing most of the channel, and then I got into the Iron Man tech, then kind of mixing and matching because I am 3D printing an Iron Man suit while I'm also working on this tech with the NVIDIA Jetson. I'm working also on a Raspberry Pi port of all the software. It's not as powerful, it doesn't have as many features, but it will run on a Raspberry Pi now. So that is something cool. If you haven't seen it yet, I'll be doing a whole video on getting my heads-up display software running on a Raspberry Pi. From Chris. We got Chris Baker. Thanks for joining in the chat. I've been a follower for about 4 years, usually here for the 3D printing, but this is great. Thank you so much. Again, trying to bring different types of content. The 3D printing space is not what it used to be, but I do want to get me some new printers and pick up some of that content. But I tell you what, my mind has been on this track now for, 2 or 3 years now, building the ultimate Iron Man suit. And so that's what I'm interested in. That's what we're doing with the channel. But I haven't forgotten about 3D printing. If you were here about this time last year, you would have seen a lot of content based upon me 3D printing carbon fiber nylon. There will be more of that coming out, as well as sanding it, priming it, and prepping it to be an Iron Man suit. So I'm not done with 3D printing, but that was the stuff that started to really interest me, more of the exotic, hyper durable material. So I want to be doing more of that. Alright, so the kernel's done building now. Now it's doing all of the installation. So these are all the files that it built during this install process. Now it's installing it to the local tree. Alright, so it says it's got R2Cam, CSI2's already pre-built, yada yada. Everything's ready to go, built for JAJ, which like I said, I assumed was just a Jetson. Now, it says that we can go ahead and flash, but I do want to add my Wi-Fi information. So let me go ahead, I'm going to switch off of this. We're going to switch to the wide camera real quick while I just run that shell script it told me to add my Wi-Fi information to it. Let's see how this works. Let's try this. I will be honest, my Wi-Fi password has a space or two in it. So I hope that works. But I'd love for it to just come up and work and me not have to fool with it trying to get it up and running. But I could. It would work. This will make life a little easier. Okay. Let me see if that file looks right. It says it created a file. I want to see if that file looks correct. Okay. So it looks like it created that file correctly. Alright. So let me go ahead and clear out that screen. Alright, now I can switch back. Thank you very much, Kris. I appreciate it. Alright, let me get below my on-screen information there. Alright, it says we can flash. So we want to connect micro USB to the port adjacent to the mini HDMI. Okay. We're going to power on with the force recovery button held. You can verify, and then we're going to verify that it actually came up. All right, let me show you how we do this. All right, we're going to switch back to the desk camera. Luckily, I have done this before on other boards. A couple of things we need to be prepared for. Let me grab one of these adapters. I didn't want to have to power this by battery while sitting on the desk, so I found these on Amazon. These are just little XT60 to USB-C adapters, and it should power it enough. I've got a high power USB-C adapter off camera, so that should power it. We need to go USB-C to my host computer, so that's that laptop I've been showing you guys. So I've got a high quality USB cable. I actually bought this from Adafruit. It's high quality USB-C cable. That is going to plug into this port here, right there. And then we're going to take and plug this into my host computer. All right. That should not power the board. All right. That is just for data. Now we need to power the board. So I have this, which I've already tested on another adapter earlier to see if it provided enough power. It should. That's all I got for you is it should. If it doesn't, I'll go get a freaking battery. I've got batteries in the garage. I can do that. All right, so this should power it up. But while I'm powering it up, I need to hold this recovery mode button, which is right here. You see that? All right, let me show you. See that recovery mode button? I'm going to hold that down while plugging it in. And it should show up on the host machine while I do that. So I'm going to hold it down. I don't know if I should show you the host machine or what. Let's just show you the board first. I'm going to hold that down. Should have put feet on this so that it would be a little bit more stable. But I'm going to hold that down. I'm going to plug it in. I'm going to hold it down. Looks like it's going to power up. Hopefully that should be long enough. I will let go of the recovery button. I'm going to switch over to the Jetson. Alright, so let's see if LSUSB is showing this device. They're saying I should be showing NVIDIA Corp APX. Looky there. It's exactly what I'm seeing. It even has the same information, 955, 7523. So I'm really happy that part worked, because that's one of the most difficult parts. But since they added that button to the board instead of me having to use jumpers or something else, that made it a lot easier. So, you know, that was kind of a big hurdle. It's powered correctly. It's running off that USB-C connector I've got. I think I've got like 120 watts on that USB-C connector, so there should be plenty of power. I'm going to copy that flash. That should just run. Now the moment of truth. We see if it flashes the board. It's not dead yet, so it's a good sign. Not exactly sure how long this will take us, so we will just give it a moment for it to do its job. And like I was telling you earlier, normally you can do this on like an SD card that's actually on the module, but we obviously don't want to do that. We need high speed, we need high performance. We're going to run off of the solid state drive that's on that PCIe bus on the back of the board. We're populating the root file system. Looking good so far. All right. I really hope that this just goes super. So far, this has been going great, by the way. I really do hope that this keeps going really smooth. If it keeps going really nice like this, then I should have plenty of time to show you the latest in my heads-up display. Some of the cool new features I'm really excited about. But this, again, my goal is to have this board be the board in my suit. That's why I contacted ARK. They did not contact me. I said, hey ARK, I saw your Just-A-Jetson board. It's awesome. It's small. It runs off of battery. This is perfect for a wearable Jetson. And so that's what I'm using it for, as a wearable computer. This is looking great. I'm going to give major props to ARK if this works just like they said it was, if they've really built all this logic into their scripts. I'm going to give them major props. It's hard. It's hard to build scripts that just work. And why do I say that? Because we've all had scripts that don't just work. And so usability, building something that makes your customer's life easier rather than a bigger pain in the butt is really hard to do. But it's well worth the time in terms of making your customers happy and not making their job difficult. Thanks everybody that's joining. Again, the stream keeps just growing a little bit larger, a little bit larger. Thanks for everyone joining us. It's about 10, 15. Oh, look at there. It just it just cut off, so I think we're rebooting. We're rebooting. Let me show you what I'm seeing on the desktop. On the desktop, I'm seeing the fan has stopped, and this red light over here in this corner is on. So I am seeing things here on the desktop. We're looking good. We got 30 viewers now joining. Again, I haven't done these streams in a long time. I'm used to pretty good crowds here, but I'm thankful for all you joining me after such a long time of not doing these live streams. I missed them. They were a lot of fun. Love hanging out with you guys. So it's looking good. Flashing the kernel. Yep. Putting all that. Yeah, it's looking great. And notice it is flashing to NVMe, so that should mean that we are flashing actually to the SSD card. Well, I don't have an SD card on the back of the module, so it has to be flashing to the SSD card. It's the only option it has. Looks like we're formatting one of the partitions. right, so it is, yeah, okay. So let me show you what it's done here. It's formatted the app partition, allocated everything, formatting app partition done. Yep. Now, if you notice this tar command, let me see, this is the system image. So what it's doing now, it is uncompressing the system image, all the root file system, that kind of thing. It is uncompressing all of that to the new file system that it just created. So now it's a matter of time for it to actually uncompress everything that we downloaded earlier, that we built that root file system. I believe, if I'm not mistaken from what I've seen before, we're probably looking at a mix of scripting that ARK Electronics has done that goes around the typical Jetson scripting from NVIDIA. And so they've adapted it just to make sure you get everything installed correctly for the new main board that they've done. When you make a new piece of hardware, things are going to be slightly different. They may be on different addresses. You may have a couple of pieces of hardware on your board that maybe the stock one doesn't have, or maybe you've left something off because you didn't need it for your application. So that's why we built this kernel from scratch, was so that everything was designed for this board. It's got the right drivers, it's got the right addresses, it's got that right mapping so that everything is configured correctly. Again, one of the reasons I chose this board was because of the battery input. Not only does it have a battery input, as we've talked about, not only does it have this battery input that we're currently just sending USB-C into, it also has a monitoring chip on that input so that we can monitor the voltage and current real time in our suit, so we know when the battery is going to die on us, so that when we know how much current is it using. We can even do things like project at the current power usage, how long will this last? If we know a minimum, for example, if we know that if it hits below, I don't know, depends on which battery you use, obviously. If it hits below 11 volts, it's going to die, whatever the minimum charge on that battery is. So that's what I'm looking forward to. I've actually started working on that code already for that chip, so that we'll be able to integrate battery monitoring directly into the heads-up display for the Iron Man suit. And so this will be night and day versus the stock board, which doesn't have this dedicated battery input. So I'm looking forward to that. We're making good progress here. You can see it is actually still doing all the flashing, all the writing. It's pulling everything out to the right place. The whole installation process is still moving along. All right, look at there. It might be doing a reboot. I'm not sure. Okay, it's got one thing I like when it does this. You'll notice it actually did a complete log. It said it saved the log so that we can actually, if something went wrong, if we try to boot this and it doesn't work correctly, we actually have a log of what went wrong during the process and hopefully can fix that. But it does look like everything succeeded. So the first thing it tells us to do next is just to try to SSH into it to see if, can we get into it? Let's find out. Look at there, straight into it, even with a, even using a DNS entry. And I think it said the password Jetson. Look at there. Whole installation process. I mean, it's a little too soon to celebrate because I haven't installed anything on it. I haven't done anything with it. But for a first step, getting the entire system installed, making sure that the install actually works by logging into it. So we do have a running system at this point on this Jetson, but that's pretty incredible. Big props to them for an installation process that went extremely smoothly. I mean, that was really, really nice. All right, so I guess what I want to do next, I don't care much about working on the console for my use case. My use case is graphical. So I think what I'm going to do next is we're going to actually switch from using the laptop to seeing if we can get the HDMI output working and seeing if the USB works fine on the board, so that all our peripherals are detected. So let's give that a shot next. I'm going to just scoot my laptop over a little bit. I can leave the SSH logged in, that doesn't matter. We're going to switch over to the desk. I'm going to show you what I'm going to do here. I'm going to unplug the HDMI from my laptop, which you have been watching this whole time. And we're going to plug that directly into the board. Carefully, I don't want to short anything out or break anything. Worst comes to worst, I will. Oh, I think I got something. Interesting. Okay. There we go. All right. Kind of a fat HDMI connector. It didn't really want to go. And then we need my USB. Where's the USB? There's the USB. All right. So this is a USB hub that's plugged into my keyboard, my mouse, everything. We're going to plug that into one of these. All right. Let's see. Okay, does my mouse work? Hey, my mouse works. All right, so now I can switch over and try to show you that. There we go. Okay. Let's see. It looks like this little screen didn't exactly come up correctly. We're just going to move it out of the way. We're going to pick a display, but other than that, it looks like everything is working just fine. All right. That's fantastic. All right. Okay. I'm kind of excited, trying to think of what to do next, but this is going really well so far. I think for the sake of, well, this looks like it's working so far, I'm going to actually shut the lid on my laptop. We're going to also unplug the host USB cable. It's not doing anything anymore. So that purple USB cable you saw me plug in shouldn't be needed at this point. I am going to just try to, basically what I'm trying to do is just clear up some room to work so that we can see how to get all of this set up. Pull my keyboard where it's usable. All right, I don't need that mouse. Okay, so this is working really well. You're seeing what I'm seeing. So this is the same desktop that I'm running on right now. I can open a terminal. If I need to, I might use the laptop again, or maybe my other desktop, just to make this a little easier, because I am going to need to cut and paste some stuff at some point. But this is looking really good. Okay, so we are going to want to build some things on here and run some tests on it. Like I said, I was going to try to run my heads-up display on it so that you guys actually got a really good feel for what I have been working on, what some of this new software looks like, and also a good feel for how the Jetson runs. I don't know if these cameras are upside down right now. It doesn't really matter. Okay, so let's get started. First thing I want to do, we are going to need a bunch of software installed. So let me go ahead and do a sudo apt install. I'm going to do that build essentials package. Not only that, but I'm going to also do git, again, default password on their installations for Jetson. No trade secrets at this point. That should be a lot of good stuff. Alright, let's let that go. I don't know if Chromium is going to be on here by default. It's funny that Thunderbird Mail isn't, but I don't see Chromium. Yeah, I'm not seeing it, so we may have to install that. Otherwise, I don't have a browser to like look things up and do what I want to install here. So we're going to do sudo apt install. Is it just Chromium? It is just Chromium. I didn't know if it was like Google Chromium or something. Chromium browser. Let's see if that does it. Basically, I just need to be able to browse to the repos that I need to download because I don't know them off the top of my head. So that's what we're doing here. Just gonna be able to get to a browser. There's also some other utilities I want to do while that's... Apparently that takes a second. Again, if you have any questions about the process while I'm doing this or anything, please let me know. I'm happy to chat while I'm working. While that's working, I don't know if we can do 2 apps. Sometimes there's a mutual exclusion on these app installs. But I know one of the things we're going to need is JTOP. But JTOP may not be a standard package. That may be one I have to look up, like a special repo to install. Yeah, and again, it's locked up. You gotta wait till Chromium installs first. I don't know what's taking so long. Don't know if I need to do some sort of special restart. Hate to just kill it when I don't actually know what it's doing. Doesn't look like I can't kill it. It doesn't want to be killed. Wow. Yeah. That was not working. Let's see. I don't know what it was doing. It's not like I have a download meter or something. Alright, while that's working, let me try something real quick. Let me go back to my laptop. We can always do a lot of this over the laptop if the Chromium browser is going to give us a hard time. Keep in mind, that Chromium browser giving us a hard time has nothing to do with ARK on this one. Don't actually know what it's doing. All right. Well. I'm going to kill it properly and then we'll figure it out. I'm running something on Snaps, which is a installer utility. There we go. Give it one more chance to try to install it properly. I don't know why it got all stuck up. What did it do? I think it found this package and it's probably wrong. Let's delete that. Well, I'll have to sudo it. If you're not familiar with sudo just says do this as root user, and don't tell me that. There we go. Don't know why it gave me a hard time in the first place. Okay. Quick question from Chris, just out of curiosity. Where did you learn your coding skills? A little bit here, a little bit there. I got my first start learning basic programming when I was as young as 8 or 10 years old, and picked up Linux and some C programming when I was in high school, and then I was formally educated in the university system here in the U.S. But honestly, most of mine is self-taught, just from a passion for computers and particularly for Linux. That's where most of it came from. But I did like and appreciate the formal education. It's stuff I probably would have never learned just being self-taught, just because that's not how I learn normally. So it was still quite useful. All right, so it looks like I have Chromium now. Let's see. Did it show up in here? There it is. There's Chromium. Will that pop up a browser? I'm getting a little spinning disk, so it seems to be doing one thing. Or not. Or not. Kind of weird. Just type Chromium. What's it doing? There it goes. I don't know what it's doing sometimes, but here we go. Now we've got Chromium. That'll help make our life a little bit easier. Let's go ahead. That's just what's trending on Google. All right, so let's go back. I want to go back to the ARK. Let's go back. Yeah, let's go back to the ARK repo real quick. I want to make sure that there was nothing else I wanted to do there. Documentation. Oh yeah, one thing I haven't covered. Let's do that while we're here. How much is this board? The board, I think this is the board alone. I think the board alone is $680. I think that's, again, they're showing it here with a module. I think the board though alone is $680. And again, please keep in mind that it's a very specialized board built for specialized equipment like drones and like what I'm using it for, wearable. So if you're looking for it, it's Just-A-Jetson. You can find it. You know what? I'll just paste this here. Again, no kickback for me on this. They just set me up. I can't post that. I'm on a different computer. Wow, that'll mess you up. I can't post it though. I just have to bring it up elsewhere. No kickbacks or anything on this for me. They were just helping me out by sending me a pre-production sample, which is what this is. So I'm going to return the favor and send people over to them if they're interested in it. That is what we're looking at, and I think I can pin that for people. Yeah. So that's pinned if you want to know more about it. If you're wondering, yes, this is for the Iron Man helmet project. Thanks, Presley, for asking. It's a very special piece of hardware, again, with the battery inputs, USB, all these specialized connectors, but with my camera inputs, all that good stuff. It had all the support I needed, but a real step up from the stock board. Anyway, if you're wondering why the screen has got this yellowish color, I have seen all of my Jetsons do this when they go through the this video converter I'm using. I don't know why this is. This is a high-end video converter. I don't know why it would be causing this yellowish color, but I'm sitting here like on my desktop and it's not yellow. It's white on the screen. So it's just how that interprets this. So my apologies if it, but I guess it's a muted color that should be easy on the eyes. All right, so that's Just-A-Jetson, and let's go back over to the documentation. I did want to follow through with something that I was doing there. Again, there's the flashing guide, which should take us over to the GitHub. Again, I know I'm going through this kind of fast, but I did this earlier. There's the flashing. If we want to, we could install the ARK OS. We're not going to do that. Again, I'm not using this as a drone right now. We don't need to flash the bootloader. because this one's already booting just fine, or it appears to be. We can change the clock speeds, which we can do later. We can install the super mode, which is the high speed mode on these Jetsons. So I can take that. Let me bring up another terminal. If I do that, it should go into high speed mode. Yep. You'll see that up here in the upper right, it says max speed super. So it's like, you know, full speed ahead. Now let's go ahead and look at, I want to install my software on it. I want to see if I can get that compiling. So let's go ahead. We'll go to OASIS project.net, which is where you can find my project. Did I spell it right? I think I did. There's the OASIS project. And here's the GitHub link if you just want to go straight to the source. And the only one I'm going to install for this video is Mirage. Mirage is the heads up. Dawn is the AI assistant. Spark is for like the hands and the repulsors and other parts of the armor. Let's get Mirage installed. Do I have 2 branches right now? Have I not merged it? Oh, that's something else I'm working on. Yeah, that may be what I want to do. No, it's already been merged to main. Okay. Let's go ahead. I'm just going to pull this down just like any of you would. We're gonna go ahead here. We're gonna make, or I'm gonna kind of make my usual directory structure that I like. Make directory code. You know, make, and then from code we can just, I'll do this. I'll go make directory, the OASIS project, the OASIS project, git clone. We're gonna clone that repo, Mirage. Oh, this code base is getting a lot bigger. Alright. I'm going to go into Mirage. I bet you, let me go ahead and... At some point I said, here's all the things you have to install. Now that I've pulled that down, let's see, do I have the README here that tells what I need to install this? Yep. So there's already, excuse me, there's already some instructions here about the things that you should have to install. Let's go ahead and make sure that we're running the latest. So we're going to pull that down first. Pull that down first. And I still missed something, but I can type in E. So that's gonna, that's 2 commands, not 1. So let's go ahead and do the update. Gotta fix my documentation there a little bit. All right. Do I want to worry about a sudo apt upgrade? I'm not sure. This may be too much for this stream. Ooh. There's only 268 things to upgrade. But some of it's GStreamer, and GStreamer is an essential part of my installation. So, boy, you know what? I'm going to say no for now. We'll do that in a minute if I need to. I don't want to break everything, so we're going to go with this instead. If some of this needs those upgrades, it will pull them in anyway. So let's just go ahead and do that. These are all the different components that we will need to install. Okay, the following packages will be upgraded. So there was a small subset of those that we need to upgrade. And then there's a whole bunch of other things, like the CUDA stuff. So let's pull this down. Yeah, Presley, the battery input is a pretty amazing feature. It's one of the first ones, if not the first one that I saw to actually have that battery input feature. That's pretty amazing to me too. So we're going to pull this down. It's going to download all these updates. While it's doing that, we may have to install SDL2 manually. Let me see if we need to do that. I still want to download SDL2. At some point, I need to switch to SDL3. That SDL, by the way, simple direct media layer. It's what I use to do all the on-screen graphics. It handles my keyboard input. It's a library that does a lot of that handling for you. It's also cross-platform, which is really nice if I ever need it in the future. But I could just install these SDL2 libraries. We can try the ones that come on the distribution as well, which is an option. So SDL2 Ubuntu package. And I don't, I have to look these up too. I don't keep them all in mind. But there we go. Those are all the dev files that we might need. But this is still pulling down all the base requirements that we need. Keep in mind, this is a brand new installation. When you install something brand new, you're typically missing all the libraries and installation and everything you need on it. Got a lot of CUDA libraries that are needing to be installed. If you're not familiar with CUDA, CUDA is like the underlying architecture and libraries that we use to talk directly to NVIDIA GPUs. And so there's a lot of very hardware-specific plugins and things that I use to get the most performance out of the NVIDIA Jetson. So that's what we're looking at here. But it means that there's more to pull down, there's more to install before we even can get started. But that's why I do try to provide this information on my website and in the readmes. I try to, unfortunately I don't go through these a lot myself. In fact, I think I could update these a bit. But actually makes life a little bit easier. I'm trying to just look through this list, see if it looks right, and I do think that this is correct. I'm not seeing anything that doesn't need to be there for general compiling and installation. Yeah, a lot of this has to be here, so we'll go with it. Make our lives easier as we move forward. I will, instead of compiling the SDL from scratch, which is what I recommend in the installation instructions, I will try to just install the ones that come with the distribution. We'll see if that works. It is always funny when you go to do this and you can download 10 megabytes a second normally, but like it goes to download all these packages and it's going, oh, I can do like, oh, this is 6 meg. That last one looked a lot slower. Thanks everyone for joining, making good progress on this. If you want to see what we're working on while that's downloading, here's the board. We've got the red LED, which red in this case appears to be a good thing. We've got the USB-C power coming in here. This is the Orin Nano 8 GB. This is not the one I normally use. I was doing this on this board because I wanted, my other board is being used. I'm using that for development. I didn't want to have to take it apart, risk something not going well and not knowing how to get it back up and running quickly and being down. So I'm just using one of my secondary NVIDIAs for this installation. I will go and replace this. Once I'm happy with it, I will replace this board with the NX, do the install over again. The install is exactly the same, so it's not a big deal. Again, I've got a USB hub plugged into here. I've got an HDMI plugged into here, which is what you were just looking at. I'll go back over there in just a minute. Let's see. An echo. Are you hearing some echo in the stream because I switched over? Maybe I have something turned on I'm not supposed to. Let me know. Sorry, Russell, if I'm lagging or if the stream's giving you a problem, please let me know. That's fine. Let me know if you're seeing another problem. But anyway, here's this. It says everything's going well on my end. We'll go back to the other input. I was just showing you the board while that's downloading, because the download is less interesting than staring at the nice piece of hardware. Anyone else having a problem, please let me know. We'll go back over here. More and more people joining in. Apparently this is a better time for West Coast, maybe. Thanks everyone for joining. We're still downloading all of the CUDA packages that we need here. I am curious what you meant, Russell, that this stream is lagging the other one. What other stream am I lagging? I don't know, maybe it's just Russell. Russell's not answering me. Okay, we're at 70% now. I have 2 live streams going on YouTube. Really? That wasn't supposed to happen. Let me check that out. That is messed up. If you were listening, I'm going to probably end up killing one of those live streams because I don't even know how it's doing that. I'm using one streamer. Let me see. While we're building. I didn't know. I didn't even know that was possible. You're right. Why did it do that? Huh. Okay. You're right. I shouldn't be doing that. So if you're watching, I'm sorry. I think I'm going to end that other stream. It shouldn't be doing that. That's really weird. All right. Let me do that real quick. I'm just killing bandwidth for no reason here. Very strange. But thanks for telling me. I had no idea. obviously. Alright, so that should clear that up. Yeah, that live development, that live development stream wasn't supposed to be the one that was up. Don't even know where it was coming from. Let's go back over to YouTube Studio and clean this up. Hey, at least we have something to talk about while that's going on. Live. That is very strange. Yeah, that was the same, like, basic information as the last one I did back in January. I will even save that one so it doesn't completely confuse people. Thanks for everyone who came over from the other stream. Again, I had no idea there were 2 live streams going. That will probably help my bandwidth. Again, I still don't know how I was pulling that off because I did not tell my live streamer to do that. Let me see, so my other live stream should still be up. Yeah, alright, that help view counts. Thanks, Crispy. Thanks, Russell, for letting me know. I appreciate that. We're done downloading now that we've had all that excitement. So the download is about done over here. And we are now unpacking those packages. That was not a healthy streaming situation. That's not good at all. Oh, it's going to sleep. Don't let it go to sleep. This should be done in just a moment, and then we can get back to the exciting stuff. Once these packages are installed, then I can go back to building my package. Can't do much of anything. Device's GPU is not supported. That's Chromium. Install should go pretty quick. I'm going to need another beverage here in a moment. When you do this much talking, it's nice to have a beverage. Hopefully everyone is enjoying their Monday night. Monday night wasn't too bad of a night to put this on. Had a good Father's Day yesterday. Spent time with family, both my father as well as my in-laws. It was a good weekend. Had some good food, good family time. This install will continue to speed up here. That's why I turned on that max N mode, so we have a little bit more speed on the Jetson. Crispy asked, love the content. Did you upgrade the Jetson Orin Nano to the Super? Believe it or not, the Nano and the Super are actually the same board. They just gave it a software kick. And so when I did the initial install on this one, it kind of got the same kick for free. So that Super upgrade was an upgrade for everyone that had a Jetson. And I appreciate it. Yeah, that came in for free. You'll see the Super up here. That Super you can set... Alright, okay. So, the Super, oh, no, that's not what I meant to do. Oh, well. The Super up there, that'll load back up, it doesn't matter. That Super that was up here, will, that's, okay. The Super that's up there, was up there, will... you'll get that for free. As the instructions showed me, it came for free. waiting for it to finish. So you'll find out if you did have an original Orin Nano, you can just do that software reinstall and you'll get it for free. I do think, and don't hold me to this, my understanding is you do have to do a complete flash on it to get the super's abilities. You're not going to just, you know, upgrade some packages and it's going to all of a sudden be super. I don't think so anyway. Normally on my Iron Man stuff, I actually have a custom power profile that basically tweaks all of the little power settings just the way I need them to run it on the helmet. The power requirements are very particular. So I have it's like 28.5 watts, but with everything tweaked just right to do that. Alright, so that's done now. That should be everything I need. Now we should be able to do this. And then there are some other STL libraries I need. I think I included those here. I need SDL2 image and SDL2 TTF. Let me see if it's that here. Yeah, this one. With SDL2 image dev, I think is the other one I'm going to need. And then hopefully this is just replacing this TTF here. Let's see if that does it. See if it knows what all of those are. It does seem to know what they all are. So let's say yes. And then maybe this will go well. Notice I'm installing all the dev packages because I'm going to be compiling my heads-up display stuff, the Mirage package from scratch. Alright, so we go back to, well, I know how to compile Mirage if everything's working. We do make, let's see, can I make this bigger for you? So let's go one bigger. There it is. Make it easier to see. Alright, make dir build. I'm gonna cd build. We're gonna cmake dot. Alright, we're missing something. SDL2 graphics. Need to update my documentation. I'm just gonna add it here. Why not? Lib SDL2 dash GFX dash dev. Let's see if that gets the last package I need. So when I run CMake, I can go back up here to show you real quick. When I run CMake, what it's going to go do is going to go make sure it's going to find my platform. It's going to figure out where I am. It's also going to sit here and make sure that all of the packages that I need to compile this are installed correctly on the system. So that is done. Let's try CMake again. All right, found something else it can't find. It needs OpenGL. Did I not put that in here? Maybe I haven't updated that since I've required those. Yep. Let's see, I need let's see, Ubuntu install OpenGL, and then I think I need, yeah, we'll start with that. And I need the dev packages clearly. Sometimes I have to look these up just because I don't remember the names of all the silly Ubuntu packages all the time. Yeah. Whatever. Is that going to get us there? Maybe it's just glue. Maybe glue will get them to me also. Let's find that out. That's a lot of packages. No, okay, those are other packages. Let's see if that's what we need. That is not what I need. That's just an ad that I accidentally clicked on. with GL. NASA, also a possibility. Did that install everything we need, or is it still going to look for it? Oh, that looks like it was it. Seems to have found what it needed. Let's find out. So if I type make, it should just make, and we should be ready to go. If there is something that is still missing, it will complain and it will error, and I will go fix it. Package has gotten pretty big. All right, good to go. Now the moment of truth. Will it run? One thing I know I need to do is it needs some of the symlinks created to the configuration and other things that are in the previous directory. So we're going to do that. We're going to do sounds. And we are going to do config. I think those are the only three I need. And notice it created those symlinks. Here, I'll show you. Created links to those directories, one directory down. All right, so if I type Mirage and type Mirage-H, it will tell me all the options. Okay, and what we're gonna do is Mirage, we want to do, this is going to be the USB cameras. I'm hoping that the default devices just work. And I don't have, no, that's not USB cameras. That's C USB for USB cameras. And then I do have two cameras, so I can tell it I have two. Let's see if that just works. And if there are any errors or anything, then we'll go from there. Well, there we go. It's way too big because I'm obviously streaming at 1080p. So watch this. Full screen it. Well, damn. That just worked. Look at that, guys. That is so freaking cool. Frame rate up in the upper right-hand corner up there. You can see it's like 150 frames per second running on this. Really, really working well. And the two cameras aren't synced, obviously, and they're upside down. But you'll notice these are independent cameras. And we're running, is that 190 frames per second, actually? Wow. I mean, it's just really killing it. There's a HUD. There's a HUD running. USB cameras and everything. Well, hell. That's absolutely wonderful. That's what we wanted to do tonight, right? So, new board, new installation, fully running HUD on this new board. That worked really, really well. And the performance is peak. Yeah, that's 190 frames per second right now. 190 frames per second we're running. And like I said, I mean, you can see how smooth it is. Like, that's awesome. These are those new global 90 frames per second cameras I was telling you about. Like, these things are sweet. These are the ones I might be putting in the next version of my helmet. The only thing they don't have is, like, night vision, which was a feature I was trying to do, but what you gonna do? Let's show you something really cool. You want to show you something really cool? Yeah, I think we can show you. All right, so let me drop out of that first. It can't download the mini map, which is why you're seeing all those curl errors. So that's those curl errors. I didn't install my map key to get the Google Maps, so you're going to see those errors. It's not a big deal. Let me show you the new piece of hardware. Let me show you the new board, because this will make it even cooler. So if I switch over to the desk camera, this is what I was telling you about earlier. This is the new helmet technology that I've got. This is a new piece of hardware. I designed the board itself. All the other pieces are from Spark Fun and from Adafruit. Let's plug this into it. It'll show you what it looks like. We're going to USB-C into here. And then this just needs to go into that USB hub. It does look like I'm running out of USB hub. Actually, this can go straight into the board. Let me make sure I get it in the right way and I don't short anything out. Alright. Now this is going to power on. There's going to be a video out on this board soon, the whole thing. So, OASIS Aura. And there's the motion sensor. You can see real time. Alright, and I can actually rotate through these screens. Sorry for the... So there's the GPS. I'm not going to do GPS quickly. I'm inside, and GPS doesn't work, but there's the GPS display. There's environmental, like it has air quality. This takes a minute to heat up. Don't pay any attention to the air quality at this point because it takes a minute for this sensor to calibrate. But there's environmental sensing, tells me the temp, tells me the humidity, tells me the CO2 because I'm going to be wearing this in my helmet, and then tells me the air quality. ESP now, that's something coming in a little bit. We're not ready for that yet. And then again, the motion sensor. So, I'll turn this over because this is the way it will be in the helmet. The display will be facing the bottom. The sensors all face the inside of the helmet. All right, so let's start this up now that this is connected. All right, start it up, but this time I'm going to add the -U to tell it that there is a USB sensor attached. This will come up just like last time. Thanks, Chris. Appreciate it. All right, let's do that. All right, so now you will see. Did it come up? Did it work? Let me see something. It is not connecting to the USB, so I need to find out why it's not. Let me exit that out. Did it connect to a different port or what? Let's find out. LS USB, is it seeing it? Actually don't know what this one shows up as. Should be seeing it. Let's see. It doesn't. ACM0. You know what? I probably don't have proper permissions to access it. So if I look at TTY ACM, which is what it's plugged in as, you need dial out permissions. I'm probably not in the dial out group. I am not in the dial out group. So I'm going to do a system admin no just to demonstrate how this works. I'm going to change sudo change mod 666 on dev TTY, and again I should have just changed my user, yada yada yada. That'll take a little bit more time. I'm not going to do all that right now, so I'm just going to do that. And now when I run it again, I'm also going to pass it a -F, which should put me in full screen mode to start off with. Now it should be able to talk to the board. Let's find out. All right, now you see, it's hard to see some of these sensors. Now you see we have a proper temperature and a proper humidity right there, right up there. Proper temp, proper humidity. Okay, that is what it is in this room right now. Okay, you can see my CPU usage, memory usage, fan usage, all that good stuff. You'll notice my little guy over here, my Iron Man, his helmet is now green, showing me that the helmet sensor array is being detected properly. If I were to unplug it and it were to go away, his head would turn red. Let's show you something. Okay, so this is one of the biggest features I've been working on for a while. This one took a lot of work. Not only that, but I have some new cool things because of this. I have multiple HUDs now. We can now switch between HUDs and show different screens. So I can tell it, I could be talking to my AI assistant, and I could say switch to the next HUD, and it would switch to the next one. Or I could do something cool and say switch to the environmental HUD. And we have multiple HUDs now, guys. This shows the environmental sensors for my suit real time. So the CO2 level, if it was able to calculate it at the moment, there'd be a heat index, there's a dew point, humidity, all this is showing up real time from this new sensor array that I have. So really excited about this. This took a lot of time because I had to draw the graphics myself, and come up with what this new screen layout was going to look like. As you can see, all the cool stuff still works. I can show this. As I tilt it, you'll see that it tilts real time. It's actually a pretty cool display, right? Real time, right? Real time. All right, so if I switch, all right, this one I just finished. This is brand new. Switch to the armor display. Shows a full-size view of the armor. And if I don't have them here. They're in the garage, I believe. If I did have them here, as I turn on different parts of the armor, as I turn on shoulders and forearms and whatever, they turn on green and you start to see their settings. You see their temperature and you see their battery usage. And so every piece of the suit is independently powered. Every piece of the suit has independent thermal sensors. And so I have complete situational awareness of the suit that I'm wearing. And again, I can just switch between these. You'll notice these cool transitions. It's got slide transitions. It's got zoom transitions. It's got fade transitions. All built into the software. All custom software. So, I'm pretty proud of this. This has been a real exciting thing to work on. And I'll show you this real time as well. This is the full HUD. As you can see, as I tilt it, it finds north. As I look up and down, it finds the tilt angle. This one's super smooth. This is a brand new sensor that I'm using on this board that's designed for AR and VR. And the responsiveness is just killer. I'm really excited about using this one. And the way that I've wired this up, the sensor, the inertial measurement unit, is actually hooked up over an interface called SPI. It's a very fast, very responsive interface. And I'm using interrupt handling so that the second that there's a change in that data, I receive it on that little microprocessor and it immediately gets sent. So the responsiveness is pretty much instantaneous at this point. So you can see, seems to like it, right? Seems to like it. Right, so let's just show you one more time. Again, all the sensors, again, the heat index is working now. It's figured out all the thermals and everything. That's Celsius up here, though, by the way. Keep that in mind. That's not Fahrenheit. Have the ability to change that. Like, you can set, like, I want these Celsius, I want these Fahrenheit, yada, yada, yada. And then, like I said, the armor display. So, oh, that is cool that works so well. I have some new software, like I said, I've already written. Let's switch back over to the desk cam. I've written some cool new software to do the monitoring of the battery. That will go into the HUD to show me the battery voltage and the current that it's pulling. Like I said, I would even like to add an algorithm that actually estimates how much longer the battery is going to last based upon what kind of battery it is, based upon, how much juice it's pulling. Oh, excuse me. So Kris is asking, has Marvel contacted me yet to do a costume design for them? No, you know what, I'll have to be honest. I talked to one person that I know at Marvel, and they were pretty quick to tell me that the problem with what I'm doing is it's too real. A lot of the stuff that Marvel does, of course, is done in post. I would love to know that they'd loved some of this in a movie. Maybe they'd like this as a pre-tech. Maybe they'd like Riri to be using some. I don't know. Riri's beyond me at this point in the movies, obviously. But like, it would be a lot of fun to have this kind of cool stuff in a movie. But anyway, I'm pretty happy doing it in real life. But I'd be happy to go to a premiere or something. That would be fine. Anyway, so here's the new board. Compact, worked out of the box. The installation was pretty flawless. It was completely flawless. I had zero problems with their install instructions. Their setup scripts worked great. The installation, the compiling of their custom kernel, all of that worked. Obviously, I have not tested every feature on this board. Haven't tested that sensor on that battery input. I haven't tried the Ethernet port. Like, there's a lot on this board that I have not had a chance to use yet. But I do want to thank ARK again for sending this over. The experience has been fantastic. It's been easy. You just watched it real time. It works really, really well. And switching right back over, it just worked. I hit the wrong key. Too many keyboards. Let's see. My Wi-Fi is a little weak. Can I improve the Wi-Fi by splitting up my antennas here or something? Because that's real time. Anyway, again, you can see how fast the real time cameras are. I don't remember what these should be pulling right now. If I switch to, let's see how many frames per second I have on those cameras at the moment. It's making a lot of noise. I'd have to go back up. I don't know if I'm going to be able. Oh, there it is. Okay, hold on. Oh, it's not even showing it because it's not pulling that up. Yeah, I don't know what the cameras are pulling frame per second wise, but here we are. Really happy with that. That worked really well. All right. Okay. Segmentation fault. I don't know why I did that, but it was really good timing to do that right before I logged off. So, again, brand new code. I just finished writing some of that. There's clearly a bug I need to fix, but that was fantastic timing. We'll run it again just to make sure. Don't think there was any problem. That was funny. Oh, I think I know what happened. I think something disconnected that shouldn't have disconnected. I get it. Not a big deal. Not a big deal. So everything up and running, looked fantastic. Again, if you have any questions, please feel free to drop a comment on this video. This has been a lot of fun this evening. So happy that this went so well. Got the software up and running. It's been a lot of fun. Thanks for your time this evening, guys. It is only been just a little over 2 hours, which worked really well. So thanks again. Appreciate everyone joining me. If you enjoyed this, like I said, please leave a like on this video. And I will do some more of these. Maybe I'll just do some real-time coding. Maybe I'll show you some more of the features that I have in mind. We got DragonCon in a couple of months, and I have to have this done. So, sounds good. Thanks again, and I will talk to you all later. Have a good night, and be safe.